I'm Mark Cyrus G. Arceo from Brayton Bernoulli. And for today's video, I'll be teaching you how to plot points on Cartesian plane and how to find distance between points using distance formula. What is distance formula? The distance formula is a useful tool in finding distance between two points, which can be arbitrarily represented as points x sub 1, y sub 1, and x sub 2, y sub 2. The distance formula itself is actually derived from Pythagorean theorem, which is a squared plus b squared is equals to c squared. The distance between point x sub 1, y sub 1 and x sub 2, y sub 2 may be found using this formula. D is equals to square root open parenthesis x sub 2 minus x sub 1 close parenthesis square plus open parenthesis y sub 2 minus y sub 1 close parenthesis square. Before we proceed to our examples, first, let's have a practice. Try to plot the given points on the Cartesian plane. Before we plot the given points on the Cartesian plane, first, let's identify the four regions of a Cartesian plane. In the upper right corner of a Cartesian plane, we have quadrant 1, which will give us the point positive and positive. In the upper left of the Cartesian plane, we have quadrant 2, which will give us the answer or the points negative and positive. In the lower left of a Cartesian plane, we have quadrant 3, which will give us a point of negative and negative. In the lower right part of a Cartesian plane, we have quadrant 4, which will give us a point of positive and negative. So let's try to plot the given points. First, we have L open parenthesis negative 3 and positive 6. As we all know, quadrant 2 will give us an answer of negative and positive. And in the given, we have negative 3 and positive 6. So our answer will be plotted in quadrant 2. Let's find negative 3 in the x-axis. Negative 1, negative 2, negative 3. And let's find positive 6 in y-axis. 1, 2, 3, 4, 5, 6. So our answer will be plotted here. Let's proceed to number 2. O, open parenthesis, positive 6 and positive 3. And as we all know, quadrant 1 will give us an answer of positive and positive. So our answer in number 2 will be plotted on quadrant 1. Let's find positive 6 in x-axis. 1, 2, 3, 4, 5, 6. And let's find positive 3 in y-axis. 1, 2, 3. So our answer will be plotted here. Yeah. Let's proceed to number 3. V, open parenthesis 5, negative 7. And as we all know, quadrant 4 will give us an answer of positive and negative. So our answer in number 3 will be plotted on quadrant 4. First, we have to find positive 5 on the x-axis. 1, 2, 3, 4, 5. And negative 7 in the y-axis. 1, 2, 3, 4, 5, 6, 7. So our answer will be plotted here. And last, we have E. Open parenthesis, negative 9 and negative 7. And as we all know, quadrant 3 will give us an answer of negative and negative. So our answer in number 4 will be plotted in quadrant 3. Let's find negative 9 in the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. And negative 7 in y-axis. 1, 2, 3, 4, 5, 6, 7. So our answer will be plotted here. Let's proceed to our examples. Example number 1. Plot and solve the distance between points. A. Graphing. Plot the points L, open parenthesis 6, 3, close parenthesis, and O, open parenthesis 4, 8 in the Cartesian plane. We are supposed to find the points L and O. First, we have to find point L. It says that 6 and 3. Let's find the positive 6 in the x-axis. 1, 2, 3, 4, 5, 6. And let's find the positive 3 on the y-axis. 1, 2, 3. So the point L is here. And let's find point O. It is positive 4 in the x-axis and positive 8 on the y-axis. 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8. So point O is here. Now that we find points L and O, let's find its distance. Solve the distance between the points L, open parenthesis 6, 3, close parenthesis, and O, open parenthesis 4, 8 using the formula b is equals to square root of open parenthesis x sub 2 minus x sub 1 close parenthesis squared plus open parenthesis y sub 2 minus y sub 1 close parenthesis squared. Let's write the given here, and let's mark point L as x sub 1 and y sub 1, and let's mark point O as x sub 2 and y sub 2. Let our line segment LO substitute on the given. Our x sub 2 here is positive 4, so we write positive 4. And our x sub 1 here is positive 6. We write the positive 6. Copy the square. And our y sub 2 here is 8. So we copy here the 8. And our y sub 1 here is 3. So we write here 3. And also copy the square. Let's substitute each. 4 minus 6 is negative 2. Also copy the square. And 8 minus 3 is 5. We also copy the square. And let's substitute this. Negative 2 square is positive 4. And 5 square is 25. So 4 plus 25 is square root of 29. So our line segment LO is square root of 29 units. The distance between the points L, open parenthesis 6, 3, close parenthesis, and O, open parenthesis 4, 8 is line segment LO is equals to square root of 29 units. Let's proceed to example number 2. Still, we're going to plot and solve the distance between the points. Example number 2. Graphing. Plot the points V, open parenthesis, positive 4, negative 7, close parenthesis, and E, open parenthesis 4, negative 1, close parenthesis on the Cartesian plane. We're supposed to find points V and E. But first, let's find point V. In the given, we have positive 4 and negative 7. Let's find positive 4 on the x-axis. 1, 2, 3, 4. And let's find negative 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. Our point V is here. Next, let's find point E. In the given, we have positive 4 and negative 1. Let's find positive 4 on x-axis. 1, 2, 3, 4. And let's find negative 1 on y-axis. Negative 1. Our point E is here. And now that we found the points B and E, it's time for us to find its distance. Solve the distance between the points V, open parenthesis 4, negative 7, close parenthesis, and E, open parenthesis positive 4, negative 1, close parenthesis, using the formula D is equals to square root of open parenthesis x sub 2 minus x sub 1 close parenthesis square plus open parenthesis y sub 2 minus y sub 1 close parenthesis square. Let's write the given here and mark point V as x sub 1 and y sub 1 and mark point E as x sub 2 and y sub 2. Let line segment VE substitute on the given. our x sub 2 here is positive 4. So we write positive 4 here. And our x sub 1 is positive 4 also. So we write positive 4 here and copy the square. And then our y sub 2 here is negative 1. So we write negative 1 here. And our y sub 1 here is negative 7. So we write open parenthesis negative 7 and close parenthesis. We change our sign here because it's both negative. So we change it to open bracket. And here is open parenthesis. Let's substitute each. 4 minus 4 is 0. Copy the square. Plus negative 1 minus negative 7 is positive 6. Also copy the square. And substitute these two. And it will give us the answer of 0 square is 0 and 6 square is 36. So 0 plus 36 is square root of 36. So our line segment VE is equals to square root of 36 units. The distance between the points V, open parenthesis 4, comma negative 7, close parenthesis, and E, open parenthesis positive 4, comma negative 1, close parenthesis is line segment VE is equals to square root of 36 units. And that would be all in this video. Thank you for watching and goodbye.